Section 3.1 talks about measures of central tendency, and a measure of central tendency is some sort of measure that we get from the data that tells us approximately where the center of the data lies. Depends on the shape, but a lot of times the center of the data, there's lots of data points there, and so it's a good thing that we like to find. Now, there's a few different measures of central tendency that we'll look at. The first one is the mode, and it's the most frequent data point. And one thing to note is that if one single data point isn't more frequent than any other, then the data set has no mode. Another way to put that is if there's a tie for first, then you say there's no mode. Other definitions of the mode will say there could be multiple modes. So like if there's two of them that tie for first, then there's two modes. It just depends on the definition. The definition we'll use in this book is that if there's a tie for first, then there's no mode. The second one is called the median, and it's the center of the ordered distribution. So you take all your data points, you place them in order, and then you find the data point that falls right in the center, or you take the midpoint of the two that fall directly in the center. So it depends on whether it's odd or if it's an even number of data points that you have, the way that you find it by hand. In Excel, there's a built-in function. It's called the median one. So like equals median, left parentheses, your data reference, and then you close the parentheses. It'll give you the median. The third one is the most common one that we'll look at in this class. It's called the sample mean, sometimes just called the average. And what you do with this one is that you add them all up and then you divide by the number of data points that you have. This capital sigma here, that just stands for the sum of. And then x sub I, this whole thing, is each of the data points, and n is the total number of data points. In Excel, the function is called average. It's equals average, left parentheses, cell references, and then close the parentheses, press enter. That'll give you the sample mean. Okay, now trimmed mean is another type of mean, so similar to the sample mean, except that they take away some of the smallest numbers and take away some of the largest numbers. When you do that, it typically is to remove outliers so that you have less skew from those outliers. And I guess that depends if you have outliers in both directions or not. But typically, if you're trimming your data, you're trying to remove those outliers. Okay, now in this class, we're going to use technology to calculate these, and you could do it by hand. It can get cumbersome to do it by hand, though. Imagine we have 500 data points. You would have to type in and add all of those 500 data points and then divide by 500 if you were doing the mean. That's very time consuming, and it's better to just use technology in order to get these things. No one does it by hand. So yeah, I put instructions here. The descriptive statistics file will not only give us these measures of the central tendency, but it'll give us other measures as well. We're going to talk about measures of variation in 3.1. It'll give us those measures, and then it'll give us some of the measures in the later part of chapter 3 as well. But it's a file that we're going to use pretty much in this course, so you have to get used to it. One thing with this file is that the data needs to be in order from least to greatest, and I'll show you that when we're using the file. There's one thing that you can check to make sure that it's in order from least to greatest. If it's not in order from least to greatest, it's not going to function correctly for all of the measures. Some of them will work right, but some of them won't work correctly. Okay, now I just said no one does this by hand, but I'm going to demonstrate doing this by hand once just so you get an idea of what these formulas are. And then after that, we're always going to use technology to calculate this stuff. So the mean for this one, we're taking the sum of all of these numbers. And there's not too many, so this makes it much less cumbersome. Add those all together. We have 1, 2, 3, 4, 5, 6 data points. This gives us do the sum first, gives us 61 divided by 6. And we do that division, gives us approximately 10.167. Okay, so we can kind of see, like, just imagine like 10.167 it's right here. This 27 is much larger than the rest of them, so it's skewing the data to the right. It's making this average much larger than what is like actually towards the center of this data set. The second one is the median, and for this one, usually like there's 6 different data points, so we got to go divide that by 2. It gives us 3. So go in 3, 1, 2, 3, 1, 2, 3. Okay, right here, right in the middle, it's got to be right in between 6 and 8, which is 7. If you wanted to use the formula itself, you can add those two together, divide by 2. It's a 14 over 2, which gives us a median of 7. Mode, most frequent one, which is 6. There's 2 6s, everything else has just a single value. Okay, now for the trimmed mean, it's saying eliminate the smallest value, eliminate the highest value. So we're taking 6 plus 6 plus 8 plus 9 and dividing. We only have 4 data points, divide by 4 at this point. This gives us, what is that, 12, 20, 29 over 4. And that is 7.25. Okay. Yeah, so these are all fairly easy to do by hand, but I want to show you the descriptive statistics file. We'll come back to this one. It lives with our other Excel file, so in content and Excel files, descriptive statistics. I'm going to download this one. And here's what it looks like. Data goes in this first column here. I'm just going to erase this, press delete, don't press backspace. And I'll put these in order. Yeah, so here's everything in order. Just want to show you what happens if it's not in order. It says down here, is the data in order? True, that's good. If it wouldn't be in order, it turns to false, turns red. So if that's there, then make sure you switch the order. So 5, then 6. And we all did this with the first Excel assessment, but right here in the home, you can sort from smallest to largest there. I'm going to do that pretty quick. Now, the reason why you have to sort from smallest to largest is because of this, the quartile 1 and quartile 3, they don't program it the same way in Excel. Like the built-in functions aren't the same as what our definitions are in the book, so we have to use a different methodology for that. It's just programmed a little bit different. So yeah, here's the mean, 10.167, gives us a little bit more data points. Mode is here, 6, which is good. Median is up here, which gives us 7, which is what we had as well. But gives us a bunch of other things as well. The variance, these are the measures of variation. And then these are other things for outliers. Gives us a box plot as well. This will be nice in our next few sections. So fairly easy to use. Make sure it's in order. Make sure it doesn't turn red. Fill from A2 and then down. But yeah, we'll be using that pretty often. Okay, let me go back to here. Whoops. And talk about a word that is important, resistance. So this one here. We've talked about outliers before, but outliers are data values that are very different from the measurements in the data set. A large outlier will make a skewed right distribution. A small outlier in comparison to the others will make a skewed left distribution. It pulls that average to the right or to the left. A statistic is said to be resistant if outliers do not affect its value substantially. Now, this resistance is a good thing to keep in mind when you're reporting measures of the center. Specifically, if you have a skewed right or a skewed left distribution, you typically want to use a resistant measurement. So to be even more specific, if you're looking for the center and you have a skewed right distribution, you would want to use the median instead of using the mean. So that's this question here. It's an important thing to keep in mind. Why is the median more resistant than the mean? The way that you find the median makes it more resistant. Those large values and those small values, you don't take into account their magnitude. You just take into account their position. So those extreme values don't have as much effect. So let me write that in a sentence here. Okay. Yeah, so there's a good sentence. Median is more resistant than the mean. Keep that in mind. Now, part B, it says, why is the trim mean more resistant than the mean itself? The trim mean eliminates those extreme values, making it more resistant. So let me write that here. So a trimmed mean usually eliminates the extreme values. Which makes it more resistant. Those extreme values have less effect.